Okay, we've just clicked over to 8 o'clock, so we might might make a start, I think. Okay. Good evening, everyone. Welcome to our second session of the Internet of Everything Capstone project. Just a couple of quick things. A reminder that all of these meetings will be recorded. We've created a YouTube channel, which links shown here, and the link is also on the edX pages. So if you miss anything, you can go to YouTube and have a listen. If you're interested in what the other groups were talking about, because each one is different, feel free to listen into theirs as well. Okay, this session we're going to keep the talking from my part anyway down to a bare minimum because we really want to know what you guys are up to and how things are going, answer questions, etc. But we will run through what the requirements for the next couple of weeks are. First one is we've been trying to keep on top of email. Think we've done most of it. If you haven't had an email answered, could you please let us know here? And in future, if you don't get an answer within 2 working days, send an email again to bring it back up to the top of our list. I'm hoping we've got everyone. Okay, everyone's in their teams, I hope. If you're sitting in a team all on your own, please let us know. And what we'll do is we'll try to work out where would be a suitable place to put you so that you've got some people there to share ideas with. We really do want to try and build on this collegial building and cooperation of the projects. So don't stay there on your own. We'll find a relevant place to put you where there is some commonality and you can help each other out. One of the things I'd like to see people do is think about...
I think you have a fairly strong case.
Yeah, we'll just wait for that to be muted. One thing I think we should try and do is come up with a name for your device or solution. It gives it some character, a bit of a life of its own, makes it easier to talk about rather than having a long description like a portable device for tracking snails and slugs across my garden. If you give it a name, it tends to focus you, it gives you something towards your marketing, and as I said, it gives it a bit of a life of its own, so we would call that Sluggo instead or something similar. So have a bit of a think about the name. It can be used, as I said, in the marketing, and it will help focus on what you're working towards. So this fortnight, we should all have submitted our canvanisers, and one of the key things here, you need to go off and mark it. Okay. Have we got everyone muted now?
I think so. When they joined, it was unmuted.
Yeah, I forgot to set that when we came in. Where was I? Oh, yes. Okay. So we've all submitted our canvanizer. If you haven't, please let us know. We'll see if we can work out a way to... Okay. But we really do need them submitted as early as possible so that the peer assessment can be done. Now, the reason we're doing the peer assessment is not so much so that we don't have to mark it. That's always a nice feature from our part, but it's so that you can go and look at the ideas other people have had. We've got a really wide range of people involved in this course, people with business backgrounds, people with technical backgrounds, people with a very limited background, which is also good for a fresh view of things. And if you go off and you examine what other people have put into the canvasser, it'll give you a very good idea of other possible solutions. So if you're one of the technical people and you've concentrated on the physical requirements for your system, the hardware platform you're going to use, the software you're going to use, but perhaps not looked too much in depth at the marketing, the income streams, you know, how you will actually make this a viable solution. If you look at one of the people who's concentrated not so much on the technical, but the business side, you can pick up some very, very good ideas from there. So it really is worth marking those too. And if you get the chance, have a look at more. And it will help gather your ideas and give you new points from people with a very different perspective. So what we'd like you to look at is listed here, but basically make sure that there are 3 problems that have been the solution. This is key to the longer term process of finalising your design. If you don't have 3, at a maximum, 3 distinct problems that you're addressing, then you can get the case of scope creep, and more things will be tried to be done, and it will just extend the project out and out, and you'll never get to a finishing point. So identifying those 3 key areas, or 3 problems that you're going to address, is critically important. Make sure that the person you're examining, their Canvanizer, have identified the customer segments. Where are they going to sell? Who would actually buy this device? The unique value proposition, the single reason that your device should exist. This is really, really important. Knowing what is different about your product. That will also help with the costing, and I'll get to that in a second. At least 3 features of your IoT device. This is really how you're going to be able to sell a point and the points you're going to be concentrating on. If you have more features that you wish to add, bear in mind that it's going to extend out your development time, and in the real world, that is going to extend out or blow out your cost. And if your cost goes up, it means you have to sell it for more, which means you might actually price yourself out of the market. So being very specific on the features that you're going to implement is, again, critical to the product's success. You need to have the channels thought about, or have some idea of what channels you're going to sell to, what the use is going to be. The cost structure. Now, that's a really interesting one, because there are a multitude of ways, or several ways, you can approach this, and we'll go into more detail when we get to the costing parts of the videos. There's several ways you can look at doing the cost. The first most common way is that if you are producing this as a normal commercial venture, the first thing you would do is you go out and you look at what your competition is. What are the features of your competition's device, and how much are they selling it for, and are they succeeding in selling it? This is actually going to form part of your formal report that you will submit at the end of this course. And in some circles we call it a literature review, but really we're looking at a market research. You need to know the features, the costs, and the availability and the success of the competitors, and you need to go out and hunt for those. Make sure that you're not infringing any intellectual property as well, which is another thing we'll be covering a bit later on, about week 7, I think, somewhere around there, or 8. But when you're looking at the cost, it's a fairly simple thing to do if you're working for an established company that has decided this is the product we're going to produce, let's get the engineers and everyone working on it. Because they will allocate a set amount of money to each of the areas of doing the development. For example, they'll give $10,000 to the engineers, $10,000 to marketing, and $10,000 to the software people. And you've got to stick within that budget. So you then know that your product cost is going to be $30,000 plus the materials to build it, plus the distribution and any taxes on top of it. So very, very simple to work out what your cost is. You then take that total cost, amortize it over the entire production run, the number you think you would sell. So divide the cost up equally between all of those devices. Add that to your production costs and your distribution costs. Put your profit margin on top, and there you go, you've got a selling price. However, if you're a person that's doing this as a startup or as a small business on your own, it's relatively difficult to work out what your development costs are. What value do you put on your own time? How much of that time that you've sunk into the development of the device are you going to try and recoup? So if you look at this course, you might want to recoup the costs you paid for this course as the first thing, and then say, put a value on the amount of time you spent developing it. And then do the same thing, spread that cost over the entire production run, depending on how many you think you're going to sell, add your distribution costs, your profit margin, and then you've got a price. But the other aspect to look at too is this a commercial product? Are you doing it to make money? That's not always the case. A lot of the things we do are actually done for philanthropic reasons or for pure intellectual curiosity. And we would price things differently. We wouldn't necessarily go out and look at the competition pricing. We would work out what margin we need to keep the device in production, to work on further developments, and then price it to match those sort of costs. So that's rather different with the philanthropic. If you come out at a cost and it is significantly less than your competitors and you're doing it for a commercial reason, then it's quite often worth not working on your base price, which would undercut the competition by too much, but to look at what the market will bear and maximize your profits that way. So if you can produce a device that performs the same function as something that is being sold currently for $100 and you're producing it for $10, you don't sell it for $20, you sell it for $90. And that way you're maximizing your returns on your investment there. So revenue streams have to be thought of, the cost structure has to be thought of on the basis of why are you doing something, how do you want to recoup the money, and how much of the money you've invested in development do you want to recoup, and then a realistic profit margin that the market will bear. So that's very important when you're trying to work out how to actually cost it. You then have the issue of revenue streams. Again, there'll be people that have concentrated on this sort of area. Are you going to sell it online? Are you going to sell it through other businesses, etc.? And the next really important one is the key metrics. Metrics are how you measure success. And in this sort of technology, it's critically important. There's an expression that is becoming quite common, and it states that you should fail often and fail quickly. And that simply means that if you set some milestones to measure whether your product is looking like it's going to be successful, finished on time, on budget, etc., excuse me, you can continue on. But if you set some nice early milestones that indicate it is unlikely this device will succeed, or there is something fundamentally wrong with the way you thought about it, you immediately drop it, kill it off, start something new. And that allows you not to overinvest in a product that has a limited chance of success. So it's actually quite a good thing to work on that fail fast and fail often scenario. Give it a try, have some measurable milestones that you can meet or not meet to decide if the product is going to be successful. And if it doesn't match those expectations or doesn't meet the requirements, then kill it off fairly quickly and move on to the next thing. And make sure that everyone has looked at the unfair advantage. That's the key advantage, like it can't be copied, or in a case of our snail tracker, it doesn't damage the animals or harm them in any way. And that's unique. Every other snail trap kills a snail, and we don't want to hurt those poor little animals. Okay, so that's what you should be looking for when you're assessing other people's Canvanizer. It should give you a really good idea if you look at some of the others on how people are thinking and make use of their skill set, which may be quite different to your own. So we've seen this before. We use it in IoT1, so I'm just going to skip over it, but you should end up with something similar to this, but I'm hoping most will have a great deal more detail, and the ones I've seen so far certainly have been rather interesting and good. So we don't need that. All right, so week 4 tasks. What we should have had done is we should have joined a topic team, posted your idea in the discussion board, provided some feedback to your fellow team members, and this again is really important because by going through their ideas, it will probably give some assistance or some guidance to you as well. There is no harm in collaboration. In fact, we encourage it. We just need to make sure that if you're using someone else's idea, acknowledge it, and in the report use some form of referencing, which again we shall go through towards the end. You've obviously decided which web conference you're going to be joining, and all the information on those is in the tab at the top of each page in WebEx, in edX. They're really similar names, gets confusing. Please watch the product development videos and use these to start thinking about the business plan for your device. I'll mention again that the videos are there as a support item. It's really not what the course is about, but they are there to help you think about the business aspects of the solution that you're proposing. So make use of them. They're written by people who have a great deal of expertise in the area, so they can be very useful. Don't forget, again, I'll mention it, make sure you've submitted your Canvanizer assignment and you have marked at least 2 others. As I've been saying all along, we need to, or we would like to have this not driven by me talking at you, because that doesn't achieve too much. We really want to have you leading the discussions. So we're ready now to open it up to questions. First one is, I think, if anyone hasn't had an email answered, please let us know now. But either put your hand up in WebEx or type something in the comments box. So Josh will then handle who's saying things.
All right, yeah, we've got you can put your hand up by hovering over your name in the participants list and clicking the hand symbol, and I will get to you, or type in the chat window. Fred asks if there's somewhere you can simply view other students' Canvanizers without having to create an assessment. I haven't actually checked how that works. I think you have access to 2 or 3 others that you mark, and that is part of your requirements as submitting your own Canvanizer, but then also creating at least 2 others. So I would have to double check the requirements there.
So I graded the other 2. I'm just wondering if there's like a resource that we can just kind of go through and look for Canvanizers that might be similar, or that we can look for reference, that we can pull ideas from without having to randomly continue to assess other folks' work.
We'll get back to you on that. Could you Judy in the morning? Judy's the one who looks after the edX platform for us. So she'll know how we can do that. We'll see if we can share the whole...
Do you prefer that I drop that in an email?
Oh, I can ask. I'll ask tomorrow.
Okay. Yeah, I mean, no rush on it, certainly. But as you were talking about, reviewing other people's Canvanizers, I know that I found some value in looking at other people's ideas in some of the different groups. So I thought that just kind of trolling around for how people completed them and what things they were thinking about would be useful.
I think it would be. It's a good suggestion. We'll see if we can do that.
Thanks.
Yeah, we'll get back to you on that. We'll put out and post in discussion boards with that if anyone's interested to find out the answer. Any other questions, either on the chat window or hands up on the participants list?
While we're waiting, if you like, we've had a couple of questions on whether to develop your own microcontroller hardware or other hardware. And it's a good point to raise. Probably the best way to handle this is using off-the-shelf equipment to begin with. If you're going to modify a board, it can actually be very time-consuming, very expensive, and if it doesn't work the first time, that would significant problems in development. So what I would suggest, if you're looking for a microcontroller, look for something you can buy off the shelf with first of all, the number of I/O ports you need, enough memory to run your program, enough data storage for the amount of storage you need to keep at any one time, and usually much more powerful than you'd need. And then once you've got your idea proven, and that's the key thing, have the idea proven, yes, it's going to work, then you start trimming down and looking at manufacturing your own PCBs or reducing the cost of the microcontroller you're using. And it's a quicker way to get proof of concept, and it's also usually much, much cheaper. And there's a huge variety of platforms out there. Which one you use is not terribly important, particularly at the early stages.
Fred or John, as the case may be, has another question. No one else has nominated yet, so yes.
Sorry, I don't mean to capitalize.
No.
I did have 2 questions. One is, do we need to think about building from the ground up? Go get the MCUs, attach, whatever our outputs and inputs into it, or if there's a product that gets us part of the way that we want to iterate upon, can we, start from there and, simply either plan to partner with that company or whatever in our in our scenario.
Yeah, another really good point. Never reinvent the wheel. If you can use somebody else's work, somebody else's product, somebody else's design, all it's going to do is increase their sales, and generally they'll want to actually join in with you as a value adder. Everything we build nowadays is built on the knowledge of others, standing on the shoulders of giants. So if you find something that's close to what you want and it's legitimate to use it, be aware that a lot of people aren't keen on reverse engineering, then go ahead and do it.
The other question I have is that I'm having a little bit of trouble finding parts. Certainly Amazon.com has stuff, and there's a couple IoT sites, but mine is a camera, and I'm looking for different places to buy better lenses than they might have on Amazon.com or something like that. So if you guys have suggestions about sites, that would be great.
Cameras, not so much. Sebastian, have you got any ideas on lenses?
Not necessarily, but any general electronic stuff, I would probably suggest looking into, I think, Core Electronics. Their main warehouse is in the States. You're from New York, if I'm not remember correctly.
Yeah.
So that should be easy to get stuff. And because I was following through the emails you sent, I would think even if you just go with something, just a very, very simple off-the-shelf camera that's capable to capture and take the image, that would be good enough for your idea, because then most of the processing of the image processing and the facial recognition is going to be in the actual base station. So I would say, as long as you have something that's capable of capturing the image, just working with something off the shelf, that should be fine. You shouldn't really need to look for
certainly as an early prototype.
Yeah, exactly. So
don't try and make it perfect for the early prototype. Can you still see my screen? I brought up a web page here from a place we use quite a lot. Is that up there?
IoT6xGroupD
Session2. It's a little local company, but they ship worldwide. This stuff will all come in from China, no doubt, but it's a nice, easy place to get lots of bits and pieces, good, reliable service. These are Australian dollars, so they might be a little high to you guys. But they've got a really good range, and as I said, the service is pretty good. So he's actually got lots of lenses and cameras.
Yeah, I see that. Thank you.
Yeah. I've used him a lot, so a lot of our student projects that we have, we just get it from there, and because he's in Perth, we get it the next day, but it'll be a bit longer for you guys.
That's all right. Thank you.
Even if you look up the model number, so we get that, you can probably just search on that, and you'll find somewhere local. That's a good place to look.
That's what I was just thinking. Is once I can see some of the different parts, I could just search for those and then find a store that also has them. Thank you.
So it's a nice place to find things.
And if anyone doesn't have a question, just to add to what Ian was saying, just to add to that, even with choosing a microcontroller with these sorts of projects, I would also suggest just going with something off the shelf. Even Arduino is a pretty good device. The reason for that everyone's suggesting Arduino these days is because it's pretty cheap. There are lots of resources online available for it. There are more interesting microcontrollers out these days, like ESP32, which is fairly popular in sort of IoT applications. The reason it's popular because it's small and there are interesting things about it. It has a couple of embedded Wi-Fi and Bluetooth capabilities embedded on the same chip. But I would still say working with something that's been on the shelf for much longer, so you'll have access to more resources to get your prototype idea off the ground, so you can focus on the project as a whole, rather than being lost kind of on the microcontroller side of things and trying to get the communication and programming for that aspect of it. If you are interested in kind of following that technical side, choosing something like an Arduino, get a prototype going, then you can always later on go back and change those aspects of it, switch it to a more robust microcontroller, switch it to something that's a bit more specialized in what you're looking for. But to get the idea off the ground, off the shelf is always, I think, better choice. Even though the end product might end up looking something that stick together with a big development board and a bunch of sensors sticky tape to it. Just keep in mind that's the prototype. That's you're trying to get
proof of concept.
Yeah.
That can also be applied to the software. You might decide to write everything in Python because it's nice and easy, but Python is not overly efficient, and it's being interpreted. It's got a few issues in a dedicated system, but it can, because it is an easy language to use and lots of libraries out there that you can use, it can do things very quickly. And then if you find that it's worth the time to invest on greater efficiency, you might then convert it over to another better language such as C, or even in some cases assembly language, so that you can get the speed out of it. But here the idea is to get a proof of concept up and running so that you know you've got something that will work and will achieve the goals that you intend it to do.
Right, we've got a question from Aditya. He has the project, which is the intelligent waste sorting bin, and it's got a couple of questions there on it. The process for developing the device, he's wanting to know a little bit more about the process for that. What technology needed to solve the sorting problem, and what is the approach to solve the problem as a minimum value product?
Okay, that's a big question. The approach is to decide, first of all, what you are sorting. So if you've decided what you want to actually separate out in the smart bin itself, you can then start looking at ways of detecting and moving the items into the right storage container. So if we take the easiest one, which would be any metal that's ferromagnetic, just using an electromagnet on a conveyor belt above the bin chute will pick up items. You can move them off to the side and then turn the electromagnet off and it'll drop it into the right bin. However, when you start to look at bottles, plastic, and separating those, you're going to have to look at different ways of doing it. And that can be very simple methods. So luckily I have one I prepared earlier. Hopefully you can see I've got just a drink bottle. If you make the hole in the bin that size and that round shape, then people will put the bottles in the right slot and you can do a check on it rather than having to determine it from scratch. And the ways you could check on it is plastic drink bottles are normally transparent or fairly transparent. So you can use a light source and a RGB detector on the other side to determine if it's clear or if it's a green colour that you sometimes get in plastic bottles. Glass stick should be a way of using the distortion of light going through clear glass to sort that. But again, this is really what the project's about. If you're deciding to separate a certain item, is it possible to sense it? Now, you may be able to do that with food scraps by looking at the gases that are coming off using gas detectors, but that really is the task. What can you find out you can detect? You're not going to detect everything, so you will have an unknown container, and then you'll have other containers for things you can tell.
All right. Is that Aditya? Oh, you had your microphone on. That hopefully answers your question. Got another question from Amit asking about help. Can we get help in software development and coding for the device from the Curtin University team if we can share the idea? And I think we have Valerie on the line as well at the moment. So one of our
Valerie can answer that one. Hopefully. She was there last time, but she couldn't get a microphone going.
Yep. Can you just repeat the question? Because I'm on a phone.
Someone is just asking regarding their project, can they get help in software development and coding for the device from the team? If they share the idea, they're looking for a little bit of guidance on that sort of things. Just wondering if you could give some advice on what they can have assistance with, please.
Yeah, certainly. If you contact us with what the issues are and what sort of outputs you're getting, whether it's about things that aren't working as you expect or how to make things faster, can certainly help with that. But we'll need some background on what you're putting together and how you're setting it up, what your environment is that you're working in. So what platform, if you're on Windows or using a Pi or that sort of thing. So what you're connecting together, and then we'll be able to help.
I'd also suggest if you're asking for help, the best way to start is via email. Send the email to the IoT Capstone email address. In the subject line, state something like Python problem or microcontroller programming issue, and then we can pass it on to the right person. So most programming would go to either Hannes or Valerie, but any of the embedded programming working on the microcontroller itself is probably better going to Savash. So best go through the main channel and then we can distribute it as it fits the best person.
All right, thanks for that, Ian and Valerie. We've got another question from Ahmed about, he has a question about the project approval. When can we get the approval to proceed with technical development? So wondering about how far to proceed at this stage.
I think I have to go through all of the Kanbanizers just to have a quick look. If you have any doubt about your project suitability, and I haven't run across any yet that really are either too difficult or too simple, just drop us an email and we can have a closer look. The idea is yours, so we're not going to say don't do it unless there's really, really good reason, such as it's impossible, you just can't do that particular task. But generally, even if you're looking at something fairly simple, it will still achieve the goal because we're looking more at the process of development in an IoT environment, looking at all of the aspects of that technical and business design. So the process will still be the same, whether you're doing something silly like we keep talking about with the snore stop and snail tracker. That's a silly thing to do, but it would still be the same sort of process. So I can't see that there'd be too many that wouldn't be suitable. But if in doubt, just ask.
And a question from Anton. Do we have a limit on how many students you can pair with?
No, not really. But
teams, I believe.
In the teams, no. As long as you can still identify clearly what is your contribution. So what part of it is yours. If you're getting ideas from other people, that's perfectly okay as long as you acknowledge it, as I said. I don't think it really matters. The larger the team, the harder it's going to be to sort the good ideas from the bad. Small groups, if it just gets down to one or two people, you'll find that you won't get enough input from others. Ideally, I would say working with 3 or 4 people is as much as you would want to go, but I don't think we need a limit as long as you clearly identify what is your part and what is ideas contributed from others.
Thanks.
Yeah, don't forget, you're all welcome to raise your hand in the chat window if you'd like to ask a question on the microphone as well. Did that answer your question, Anton? Yes. Yeah.
Yes, that answers my question. Thank you.
Yeah. Okay. Yeah. Bolarinwa asks, what's the advisable way to wirelessly transmit data generated from an Arduino to a Raspberry Pi? So wirelessly between Arduino and Raspberry Pi.
Good question. And the answer is whatever you like. However, it really depends on what data you're transmitting, how far you want to transmit it, how much data you've got, can you accept some packets being lost, and the range of other things. So if you could let us know what data you're actually transmitting, then we can give you some idea.
Current data from the current sensor within a home environment, the Raspberry Pi.
So you'd be the person, this is on a person?
Hello?
Is this on a person?
Yes, this is Dapo. This is Bolariwa. I would like to transfer the data over Wi-Fi using from the Raspberry Pi to from the Arduino to the Raspberry Pi. What is the advisable way to do it?
Okay, there's a range of things you can do. What you need to know is how many bits per second you want to transfer. So how fast are you transferring and how much data you're transferring along with it. The simplest way is to use Bluetooth if it's under 10 meters and your bandwidth requirements are less than 1 megabit per second. But also bear in mind that at 1 megabit per second, there's a reasonable amount of overhead. So you're probably only going to get, safe bet, 150,000 bits per second through a Bluetooth connection. The other thing to look at as well is if these devices are battery powered, particularly from the Arduino side, you don't want to go to something like standard Wi-Fi. That's extremely power hungry. So you'd be wanting to look at something a little bit more low power. And if you've got very low bandwidth requirements, a few hundred bits per second, then you could look at something like LoRa. And LoRa is very good for long range, very low data rate communication. So what sort of distance would you be looking at?
Maximum of 50 meters.
50 meters.
Yeah.
Yeah. And battery powered device?
Yes, battery powered.
Okay. And the data rate, any idea how much data you'd be sending?
Well, at least maybe just not necessarily much, just maybe some bits per second or per minute.
Okay. I'd seriously consider looking at either low power wide area network or probably better LoRa. LoRa is a very good one to be using. I think we can get you some info on the point-to-point communication, but if we go here in the IoT store, because it's nice to look. NB is good, but probably too much power. Where's that LoRa? Yeah, we'll do a search. Okay, so if we look at these sort of things, there's a LoRa shield for Arduino, and you would be able to hook that up at a point.
And how would the Raspberry Pi connect to the Arduino over LoRa?
It would still have a LoRa, so you'd have a LoRa on the Arduino and you'd need a LoRa communication on the Raspberry Pi as well. So you need the send receive at both ends on the same protocol setup. This may be a case where you might want to apply temporarily, and then see how your power consumption goes and how your bandwidth goes, and then spend the extra time later, after you've done the proof of concept, to move it to some other low power technology. Because LoRa can be a little bit tricky to implement. It's a very new standard and it doesn't always work as you think it would work.
Thank you. Thank you.
Can't see any other questions, but did you have another part to that question, Bolarin, about how using the data generated to design a real-time graph in Python? Is that, you're wondering more about that?
That's one for Vel, if need be.
Yeah.
Yes. I'm working out the data generated from the Raspberry Pi to create a real-time graph from the Raspberry.
Are you
okay?
Yeah, thank you.
Yeah, yeah. I might need to have that have an email about that because it's quite hard to pick up what's being said, and I need all that information about the platform. So just trying to work out what platform you're using, because the Python code will change depending on where it is.
Well, he did mention Raspberry Pi, which means Linux, no doubt. Python development for real-time graph of the data as it's coming in.
Yep, I'd have to look into that.
Yeah,
sorry.
Fair enough. Send an email through to and market attention Valerie, and Val will get back to you, no doubt.
Just through to
Thank you
the
very much.
IoT Capstone email address.
That was a
And
suggestion from a student.
oh yeah, there's a suggestion from Spiridon of matplotlib in Python. All right.
You'll probably find there's plenty of libraries already out there for the Raspberry Pi plotting of data. If not, you could connect it through to a dashboard. I'm trying to remember what that dashboard was we did this morning. Can you remember what it was again?
Yep. So matplotlib's really good for plotting in Python, but it is the real-time aspect that's the challenge there.
I was actually looking for the platform we used before, which is actually really good for generating the graphs and things. I just cannot remember what it was called. I'll just look it up, talk amongst yourselves, or ask another question.
Yeah, I can't see any hands raised or other questions unless I'm missing some. So is anyone else who would like to go next with another question, if there are any?
The thing works. I think the thing works. The thing works. I can't remember what it was. But there are a lot of platforms around which will actually do the plotting for you. So all you need to do is set up the connection between the Raspberry Pi and the cloud platform, and it will do all of that plotting and monitoring for you in a nice GUI, which are very, very easy to configure. Wasn't ThingWorks. I just can't remember the name. I'll post it up a bit later on when I remember what it was. It was this morning we had a look. Is anyone here using inertial measurement units in their project? That's the one. That's what I was after. There we go. So hopefully you can see that this is the kind of dashboard you can create very, very simply with Thingiboard. It's open source, so you can modify it how you like. Nice and graphical. Bit of an ad for them. And we've used it in courses we've run in Burma, and it works rather well. So it does lots of visualization for you fairly simply.
Is asking about the LoRa network deployed in the Curtin University campus. Wondering if anyone can share any experience of deploying devices in that network and any insights on comparison between LoRa and NB-IoT or LTE-M?
They're quite different, particularly the cellular system. The cellular system is fairly power hungry, very short range, relies on a fixed infrastructure by some provider. LoRa you can actually implement yourself and have your own LoRa network set up. The data rates are also very different. LTE is very, very high data rates. LoRa is very, very, very low data rates. We've connected a few things to the LoRa network. In fact, a lot of the building sensors that we're playing with in one of the projects uses the LoRa network. Range is great. We can actually get to the CBD, which is 5 kilometres away, for those who don't know the Curtin campus, with our LoRa network. However, I mentioned it's a new technology and it's really, really finicky to set up. You'll think you've done everything by the book, you'll have everything supposedly working, and they just won't talk to each other. So there's compatibility issues between different vendors' implementations of LoRa. It can be difficult. It's definitely worth investigating. But as I said, to do a proof of concept, you're probably better using something more established, something a little simpler to set up, such as Bluetooth or standard Wi-Fi. Make sure the rest of your system is working, and then look at the communication link as a separate issue. Does that answer the question, or more warning?
Amit, was that your answering your question, or I can't see any other questions at this stage? Otherwise,
Yeah, that's. I think that's a pretty much. It gives me a pretty much good idea on that one. Thank you.
Yeah, we've actually used an Arduino LoRa setup. You can buy a kit for less than 100 Australian dollars, and it has an Arduino shield for the LoRa, an Arduino shield with LoRa and GPS, I think, from memory, and an access point.
Is that the Dragino thing here?
Dragino, yeah.
Yeah.
And we've had some success and some really horrible failures with it too, simply because of that relatively new technology, and it doesn't always work in situations where you would expect it would. But LoRa is great. The range is fantastic if you've got low data rate application.
Yeah, I have another question. But if the LoRa compatibility, LoRa has a compatibility issue or something, then because can we, if we go for the cellular communication, it will make more viable. I see there are some modules which, like for the LTE module or the 3G module, it will increase the cost. So there are any alternate solution? Because in my project, I'm trying to develop some system where we can deploy some sensors, and then municipal corporation can monitor all the sensors in a remote data center. So I think that will make a system more costly if I go for the cellular systems. Or
yeah, it would. That was kind of quiet. I think I got most of it. But it sounds like in your particular situation, the network connection method is a key part of the solution. So therefore, it's worth investing the time in getting either LoRa or one of the other low power, low data rate protocols working. There is another one that's worth considering if it's in your area, and that's Sigfox. Sigfox is a proprietary one, but you can access for free. But it requires Sigfox to have actually put the infrastructure in your area. So if it's there, it's a handy one. It does actually work a lot more reliably than LoRa, but it has that disadvantage of being a proprietary network that has to be installed by somebody else before you can access it.
Okay, understood. I'll try to investigate further more on that now.
Okay, we've still got a few minutes. Has anyone got anything else they'd like to talk about?
Another question from Bolarinwa. Is it possible to create an app on the Raspberry Pi for back and forth communication with Arduino? Or how can a GUI app on a mobile phone or web dashboard communicate with Arduino via the Raspberry Pi?
Yeah, that's a fairly straightforward thing to do. All you need to do is you set up some form of communication between the Raspberry Pi and Arduino. Now that can be wireless using the Bluetooth LE. You could set it up on the serial communications, the SPI, I2C, however you connect that up. And there's libraries available to read whatever you want from the Arduino. And then you run the server side from the Raspberry Pi itself. So if we look at something like ThingsBoard or just a standard web server, you can create all of that information on the Raspberry Pi, because it's a full Linux machine, and then just access it via the IP address via the wireless Wi-Fi network. That's probably the simplest way of doing things. So you have two separate communication channels, one between the Arduino and the Raspberry Pi, and then you have the Wi-Fi type network connecting the Raspberry Pi out to the internet, and you just connect through the internet. Would that suit your particular application? You could also use middleware like ThingsBoard if you want.
Are you there, Bolarinwa? Or
Yes, yes, yes.
Yes, yes.
I'm concerned about the required programming skills for everything. I'm concerned about the having an Android app on the phone that will have a dashboard that has maybe like options and the app and the device is connected to the Android. So I'm wondering how and how will I go about it?
I didn't actually catch much of that at all. Did you, Josh?
No, that was coming through quite muffled on your microphone, I think. Couldn't quite hear it.
I'm breaking up a bit, yeah.
Maybe.
Can you type that in and we can answer it for you?
Okay, no problem.
Yeah, thanks. Okay, so we've got to make an effort to get all of the Canvanizers available to everyone. If you have any objections to your Canvanizer being looked at by lots of people, let us know and we'll exclude it from the share if we can.
Yeah, I'll try and check with Judy on that tomorrow as to whether there's a good way to do that, or the best way to do it, in case I have something that's in place.
Shame no one's doing anything with IMUs. I like IMUs. They're my favourite sensor. Everyone's got to have a favourite sensor. One thing I will mention, I think I probably mentioned it at one or two of the other groups. When you're looking at sensors, remember that in a lot of cases you can use sensors for not for what they're intended for. So if we look at the way we measure salinity of water, we actually measure the conductivity. We're not measuring salt. That's a very straightforward example. But in a lot of cases, we can use sensors to detect what we want to find, not what they're designed to find. So it's really the case you go back to the very basics of what the sensor can detect, then look at the properties of what you are trying to detect, and see if you can match it up through some other way. So, for instance, we were talking about the plastic bottle. There's no sensor that I'm aware of that will actually test to see if this is really plastic, but we can use the propagation of light through plastic to determine what material it is and differentiate plastic, say, from glass, which is not what it was intended to do, but you can actually use the sensors differently. And that's particularly true of conductivity, acidic levels for pH, etc. Colour is another good way of looking at things, and also detecting some gases. So if you look for a particular gas in rotting garbage, you'll be able to tell if the bin needs to be emptied. And you do that through a methane sensor, which are quite commonly available. So we've got that information yet?
No, I can't see the question as yet. And Fred was suggesting posting the read-only link. Of course, that's important, that it's the read-only link to your Canvanizer rather than the full share. Posting that to your original post of your idea so that people can have a look, so it matches it up with your idea. Yeah, that could be a good idea if someone wants to. That's no problem with that.
Well, if we can't do it the easy way through edX itself, then perhaps we could put some instructions on how to do that and request that everybody who's willing, share their idea that way.
Right. The questions come through from Bolarinwa now. The IoT idea he has would require the user having a real-time graph on a mobile phone and also have control of devices connected on the same app. The intermediate devices are Raspberry Pi and Arduino, and I think I've got him halfway through his question. He says, but the mobile app is what he's...
the mobile app...
That's the rest of the question.
Probably, and please chip in any time. The easiest way to do this is through a web interface. So you actually only run the browser on the phone. And then you can run something like Thingsboard or have your own web server running on the the Raspberry Pi, which would then feed the mobile phone just through a normal web service. That's probably the best. But one thing to bear in mind, how real time do you want it to be? If you're doing that, you're going to end up with all kinds of network latencies, which may or may not have any impact, have an impact on your solution. So if you were checking the temperature of a nuclear reactor core, you probably wouldn't want to do it that way because you need millisecond accuracy. Whereas if it's just the moisture level of your garden, then 30-second delay is not going to make any difference. Anything to add, Valerie? Better idea?
No, that's a great idea to go through a web interface instead, because that gives you lots of options and you don't have to worry about Android versus iPhone versus all of those things as well.
Okay, well, we've got 5 minutes left. I'll hang around for a little bit longer, but if nobody's got further questions, thank you for coming along. I will put the recording up as soon as I possibly can. Actually, I'll bring that up so you can see where it is. This is our channel. We've got all of them up until this particular one. Feel free to listen into any that you feel like. As I said, we're trying to run these driven by you as the students. So each of these sessions will be hopefully quite different after we go through the basic requirements for the upcoming fortnight. Did we confirm everyone's got answers to their emails now? Anything outstanding, please resend it so I can pop back up to the top of the list and accept our apologies. We have been trying to get to them as quickly as we can. If you're having a significant problem, email us, and if need be, we'll arrange a one-on-one chat with me to try and sort things out. Okay.
All right. Yeah. I can't see
everyone.
any other questions. So
I'll hang on for a few minutes anyway.
They're asking about the channel name for the YouTube channel.
IoT6.
Oh, you got it there. Yep, he's got it. Yeah. So I believe that's an unlisted YouTube channel, so it should only be visible to those of us in the course.
I'm not sure how I set it up. I know the videos are public, but whether anyone would find them or not, I'm worried myself.
They won't show up in any searches theoretically. They should just be available to those of us with the link.
Yeah, to the channel.
Mm-hmm.
Okay.
And that link. Oh, okay. Search for IoT6.
I don't think it's hidden. I can always hide.
Okay, so it's not that one. Okay.
No, I didn't think I did. I didn't see any point. But if people don't like the idea, no, I'll just make it unlisted. I also have my own channel. If anyone's interested in seeing some of the other projects we've done, bring it up. I'm trying to get some more videos of our real fundamental research as well. Why aren't you working? Oh, there we go. Back to me. From here, isn't it? So we have a few videos you might actually have seen before. Yeah, that's a famous one, Josh's tilt maze. And some of our IoT work on intelligent white canes for assisting, for helping vision impaired people navigate unknown indoor environments. So, see if that works. So this is a set of inertial measurement units mounted on the, still doing that. But anyway, it's there somewhere. Using inertial measurement units to synchronize the white cane usage with the step, measure the step distance, the direction the person is walking, and build a map of the environment they're moving in. So it's a nice little project. Okay. Time is up, and if there's no other questions, we should finish.
Yeah, no other questions that I can see there, so thanks everyone.